Practice that today, and we did a little bit of, what else have we done? Product rule, quotient rule, chain rule,
Yeah,
power rule, all the basic
stuff.
stuff, right? So this particular unit is kind of twofold. The first is just, let's review derivatives. It's sprinkle a little new into it, and then let's review integration and sprinkle a little new into it, okay? So sometimes you have to switch gears a little bit. I do want to go over the derivatives of the EX and stuff like that to make sure we have a comfortable confidence level with it. As far as the test is concerned, there's one, maybe two problems total on derivatives. So I wouldn't stress over going and doing all 100 of these problems. Do you see what I'm saying?
Mm-hmm.
It's going to test that you understand how to use the quotient rule. Do you understand how to put like the product rule with the quotient rule? Maybe having a trigonometric function with a quotient rule. So it's just going to make sure that you understand how that works. So as far as that worksheet is concerned, do what you need to do on it, you know, but don't hurt yourself trying to get all those problems done. Am I making sense?
Yeah.
Okay. All right. So the next thing that we're going to work on is just the basics of, I have to make copies, the basics of integrating, but I do want to do one or two of the derivatives with EX. Sorry, I'm trying to find the paper. So, review, what's the derivative of sine?
Cosine.
Okay, everybody cool with that?
Mm-hmm.
Okay. Sine squared is written like that. Are we good?
Mm-hmm.
But sine squared also is written like that.
Yeah.
They mean the same thing. Okay? So,
Oh, yeah.
ah.
Cosine of x in parentheses squared. It's a derivative.
No, it's chain rule.
Oh,
You
no.
have to use chain rule. What's the outside?
2.
The squared, right? What's the inside?
The sine of x.
So let's now that we recognize chain rule, how do we do it? Well, we take the 2 to the front,
Yep.
we write the x, and then it's to the first,
Then the individual
and
pieces.
then what's the derivative of sine?
Cosine.
There is the derivative of it.
Okay.
Do you see the difference?
Yeah.
Yeah. How about something like this? Sine of 3x. Again, chain rule. Without you really knowing it's chain rule. Okay? What's the outside here? 3, 1, 3. Sine.
Oh.
1, 3, 1 sine. Okay, so what is it? That's a good question. Okay, let's look at this. Right? So how do I take the derivative of sine?
Cosine.
It is cosine. And it's really, if you are thinking about it, if I'm taking the derivative of this, then I am actually using the chain rule without really knowing I am. Because the derivative of sine is cosine. What's the derivative of the inside piece? Well, it's 1. Because the derivative of x is 1. Does that really matter?
No.
So what's the derivative of sine? Cosine.
Yeah.
Over here. The outside shell is the word sine. It's whatever the trigonometric function is. It would probably make better sense if it looked like this. Is that more recognizable that the outside shell is the word sine?
Mm-hmm.
And the inside is x squared plus 1?
Yeah.
Yeah, it does, right? So what about this? So the outside is the sine. So remember, the derivative of a chain rule, you take the derivative of the outside, and then you multiply it by the derivative of the inside.
Oh wait, is this sine of 3x?
Yeah. Is it sine cube?
Sine 3x,
Oh,
not
I
cube.
was sine of the.
Oh, sorry, cube, no, yes. I'm trying to make
Okay,
it
that makes
here.
sense. Yeah.
Okay, so we're on the same page
Yeah.
now?
Yeah.
Better?
Uh-huh.
That looks upside down. It's really pretty. You got it. Okay, so what's the derivative of the outside?
Sine. Or
Cosine.
cosine.
And then what do we know? When we take the chain rule, we leave the inside alone, right? So what would I write here?
3x.
Yeah.
Right. And then what's the derivative of the inside?
3.
I'm just going to put it out front because it's prettier out there. Does that make sense?
Mm-hmm.
How about this guy? Sine x squared plus 1. very obvious the outside is the word sine.
Yeah.
So cosine,
X squared plus one.
leave inside intact,
And times 2x.
times 2x. That looks like an 11 or an h, none of which are part of the answer.
Honestly, from the top one, it sort of looks like a TI.
Yeah, I was confused.
That makes it even better. TI.
And the 2 looks like an ugly Q.
Oh dear.
Like a hook. Yeah.
It's been a long day.
I remember doing a problem one of my first years teaching, and I had it up there, and I was so proud that we finished it, we got it right. They're like, do you realize you write the number 2 different every time you write it?
Yeah,
And I'm
I
like,
was
no, I
thinking that.
don't. And then I look, I'm like, oh my gosh,
Yeah.
yes, I do.
I did the same
I
thing.
got a 2, and then I got a weird 2, and then I got another looking 2, and then, oh, we fixed that 2, thank goodness.
It's just for the squared.
It's weird.
Yeah, for the squares you write them
It's,
different.
yeah, it's like I write it weird, yeah. Anyway, long story short, I tried to fix it. Obviously, it worked. So, okay. Let's look back at here. I want to do,
3 hours.
you want to do 3 hours of work?
It's like every
No,
day.
we're just talking about how much
It's
sleep we've
nothing
gotten.
new.
Why, did you have English?
Oh, no.
Oh, we were-
I'm not worried about that class. I'm not worried
Why did I
about
point out
You
English?
actually
Because
read
that's,
the book.
Lit.
EJ used to go, oh my gosh, I got to read 10 chapters. Well, why didn't you do it all along, babe? You're stressed about the weather?
That too.
Sort of. It's more of like work plus the weather.
Gotcha.
So I'm really
So
feeling
easy to
it
just
yesterday,
do.
and I can't help it.
It's gonna.
We ran out of French fries yesterday.
Is this number
At
9?
McDonald's.
Oh, I would have raised.
Which
Sorry,
quadrant?
French fry machine broke.
Okay,
Right,
second
this-
quadrant.
We don't have French fries.
Which second? Like if it's a unit circle? 1, 2, 3, 4?
French fries?
It's to the...
Sorry, top right.
Yeah, I'm doing it like a unit circle.
Okay, I'm with you. So this should be the first quadrant for you.
Ice cream machine door.
Yeah, I see.
We ran out of nuggets, base fries.
What the
And
heck?
we broke the freezer.
I ran out of my will to live.
Yeah, yeah. Behave.
That's on the recording.
Oh, dang
What happened?
Bread,
being funny.
peanut butter,
Oh, well,
and jelly.
Well, let's get back to the
He's being
problem.
funny. Let's get back to the problem at hand.
Ramen,
Okay, so
everything.
here we are. We have e to the 9x. X is 7 plus 1. Now, clearly they're multiplied. Yes?
Yes.
Clearly they're 2 totally different things. Yes, no, maybe so?
Yes.
Okay, so let's go through the process of thinking. In my brain, I think I know because it's multiplied, I have to use product rule.
Yes.
Right? I also know that I'm going to have to remember the derivative of e to the x, which dumbfounded me last week. And then I know that. So let's
But
go.
how do we?
We're gonna.
Yeah, I know. I'm trying to figure it out on my own. I don't get it.
9x to the 9xe to the 9x minus 1.
Let's just do some problems with E and it'll
Let's
make
try it.
sense.
It makes sense, hopefully, right? So, because you were absent and you missed that day.
We're including more than the alphabet.
I was here. I still don't.
Okay. So for us to do it, you take the derivative of the first
Yeah.
times the original second. Okay?
Right.
So the derivative of, let's go back, the derivative of e to the u
Yeah.
is going to be, rewrite it, e to the u,
Yeah.
and then take the derivative of the exponent and attach it to it.
So it's really nothing changed.
So 9e to the
What is the
9x.
U
Right.
stand
But I wrote that and it
u
didn't
is
make sense.
anything other than x.
Wait, the derivative of the exponent?
So what is u in this case?
9x.
There you go.
9x to the E.
What would the u be in that
Oh,
case?
no, 9.
X squared plus 1.
Right.
So it's just like it is.
Right. So if it would it be better if I wrote e to the u times u prime?
Yes.
Would that make people feel better?
Mm-hmm.
No, maybe it doesn't.
It makes more sense like
For
that.
some people it does.
See, I don't understand why that was so difficult to understand
So you do-
last week.
Me neither.
So,
Okay, so
That makes
so
sense.
it's e times the exponent. And
so
then
it's
the
leave it
derivative of
as
the
right. So
exponent,
e and leave the exponent as it is.
And then
and
the
take
derivative of the
derivative.
exponent.
And what's the derivative of the exponent?
9.
I'm just going to stick it out front because it feels better there.
Oh.
There, the derivative of the first is done. Are we feeling it today?
You just take e to whatever power.
Times the
Yep.
second. We're not playing with it. We're just leaving it as is.
Yeah.
So remember, product rule, derivative of the first times the second,
Plus.
plus
The first times the derivative of the second.
the first, and then what's the derivative of the second?
7x to the 6th power.
And you have finished your derivative. Now, you could, if you wanted to get adventurous, you could factor out e to the 9x.
Is it more points?
Why
See,
not?
I still don't understand how to clean it up.
Okay, so
I know, I get it.
like this is in common with this, yes?
No, I recognize it, and I understand how to do it. I just don't.
Just don't.
Just
If I'm cleaning it, I
And
have,
especially when
I
they're
have
negative.
9 left, and I have x to the 7 plus 1 left. And then that's gone,
Yeah.
times, and that is kind of probably the cleanest you're gonna get.
Yeah.
Yeah.
See, like
that,
when they're both positive,
but
That's
Ex-
not bad.
the ones that we were doing
Yesterday-
yesterday, where we were taking out like 2 and they had to be opposite.
Right.
something to the 2/3 power.
Right.
yeah, and when they were negative,
Okay, so there's my e stuff, yes.
Okay. Do you bring the 9 to the front because x to the 1 minus 1 is 0? So it would just be 9? I'm confused now.
Okay, so the derivative of e to the 9x would be e to the 9x
What was the third?
times the derivative of this. What's the derivative of that?
It would just be 9.
That's where it goes.
Okay, but the derivative of that's 9 because x is only to the first power.
Yes.
Correct, yes, yes.
could you? What you could write?
But if,
Uh,
yeah.
You could exponent the exponent. Would they do that to us?
What does that mean?
No.
Oh.
You would square the exponent x. Like, would they do that to us?
Yeah, they could, so what would the derivative of that be?
18x.
Yeah.
They could exponent the exponent.
Yeah.
They could put 9x squared. For the
Okay,
exponent.
so
Ruin our lives.
back over here.
Wait, is that the answer?
That's it, done. Really, truly. In calculus, I want, can you do the calculus of the problem?
That's it.
The algebra falls into play. 9 times out of 10, it's going to go, okay, now find the slope when x is 0. So you would plug a 0 here, and a 0 here, and a 0 here, clean it up, and you have your slope.
What is
It's just a number,
It's like 2 point something.
2.7-ish.
Well, I mean, 9, if you plug in 0, that'd be 1. So.
Yeah, so you'd have e to the 0, which is 1, and then you'd have 9, 0 plus 1, right, 9, and then plus 0. So what would the answer be? 9, the slope. Which
Yeah.
is very conceivable. And then at that point, you could find the equation of the line or whatever you're going to do with it. But sometimes mistakes happen if you try to clean it too much first. The cleaning of it, it could cause issues, yes.
If you set a derivative equal to 0 and then solve for x, does that give you the origin?
No, what does it give you?
Stationary value.
Stationary values, which are what?
Your x and your y's
Of the
graph.
your highest or lowest point.
The max or the min. Yeah.
So it's these guys. It's finding
So the
those
vertex,
points right there. Well,
If it's a quadratic.
If it's a quadratic, it's a
Yeah.
vertex. But if it's, you know,
It's your max and min, right?
that's the word.
Setting the derivative equal to 0?
Yeah,
Yes.
Okay.
yeah.
Then what happens when you plug 0 into the derivative?
That gives you the actual slope at that particular point.
Okay, I need to write that down.
If they say when x is 0, you're finding its slope at that
Because I
point.
can't remember that.
Any number that you plug in, like I could say plug in 1. When I plug in 1, I'm finding the slope at that
So
point.
there's never any weird random reason to plug in a 0 into the x unless it says
They'll say plug in the 0.
plug in a 0.
Yeah.
Okay.
This is just derivatives with some extra, like on steroids. Yeah.
Right. And we did it last year. We did derivatives, and I introduced the product rule and the quotient rule to you and the chain rule, not because it was going to be tested at the end of the year, but because I knew when you came into this situation, at least you have, a comfort level with something. I'm not introducing e's and ln's and all that, and derivatives at the same time. Whew. Okay, so what happens here? It is in the format of, right,
Yes.
so you see that, right?
Yes.
It's something divided by something.
Yeah.
So I know that low D high
Minus.
is high D low over low low is probably the way I'm going to go.
Yeah.
Okay? Right. So let's start. So low. So far not bad.
Yeah.
And I suggest put parentheses around everything that, like every step you do, put a parenthesis.
Every term.
Yeah, I would, because then you can start to see where the individual terms kind of are separated. So here's low, good?
Mm-hmm.
Okay, D high. So Noah, tell me, how are we going to find the derivative of this? So 5 does what? It just kind of goes for the ride. Okay, and Noah's helping me now. I have e to the negative x. So what will its derivative be?
The negative x is 1.
E to the negative x.
Times -1.
Y times -1.
Because it's the derivative.
Of that. So I'm just going to pull it up front. Why? Because I prefer the number up front. We'll clean that up in a second. But if there's a negative, I'd like to put it up front because I don't think it's minus something. I don't want to get confused with that. Yeah.
But you could have -5, right?
Yeah, I could have -5. I could pull -5 to the front even if I
So
wanted
it
to.
doesn't matter as long as you.
Correct.
As long as you account for the negative.
Yeah. It doesn't matter where you put it because this, all of them are multiplied, so it doesn't really matter.
Okay.
Okay, so low, D high,
Okay.
Yep.
minus high, not changing much.
Mm-mm.
Okay. D low, put in parentheses again, D low. So everybody agree X is just 1.
Uh-huh.
Okay. 1 plus the derivative of e to the -2x. Well, you leave it like it is and multiply by what?
-2.
Bring the -2 out to the front.
I put it right here.
So 1 minus
Yeah, 1 minus that.
2 e.
Now, there's not a whole lot of cleaning that I would want you to do, but let me talk out loud. On either side of this minus, I see 5e to the -x,
Mm-hmm.
and I see 5e to the -x. I see things that are in common,
You can pull it out.
so I would pull it out. So 5e to the -x, you don't have to really clean, but I'm just showing for future reference, yes.
You can actually pull out -5e to the -x, because
Okay.
remember you had that negative?
Okay, so if I pulled out negative, that's gone.
Yeah.
You agree?
Yes.
That's gone.
Yes.
That's gone.
Mhm.
What's left is this.
Okay.
So this and that. Now, you suggested if I pull -5e to the -x, what am I going to put here now?
We put the plus
Very
sign.
good, plus.
Yeah.
And then that's left. 1
Minus 2.
minus 2e to the -2x. Are we
You put
good?
that all over low, right?
So,
You gotta do low.
I forgot the low.
Combine like
We'll
terms.
put it down. I can do it, yeah.
You just put it on the bottom, yeah.
so it's x minus e to
Minus
-2x plus 1.
There. And you can clean that up a little bit, right? Because you'd have x plus 1 minus that. Do you have to? No.
Not really.
Am I cool with this being your answer? Yes.
As long as you put it all over.
You need to put it
As
over
long as you
low,
put it
low.
all over low. And I'm truly looking. Do you have a negative? Yes. Do you have a 5? Yes. Do you see what I'm saying?
Yes.
I am looking for that in your answer. If I see all the components that I need to see, check, you got your points.
Mm-hmm.
Yes.
So on our tests with you, we can just do the first step and then not clean?
Correct.
Okay, and also, could you, in the brackets, combine the e to the -2 of that
Yeah,
one?
you've got one of those guys minus 2 of those guys, so it's negative one of
So
those
you
guys.
just- okay.
Okay, so are we feeling a little, yes.
If we, like, simplify.
No. I don't want you to feel like you're gonna have to simplify it because it's gonna be wrong.
Miss K?
I just don't want that to happen. You're gonna lose points if you do it wrong, simplifying on the AICE exam.
Okay.
Yeah,
Can we do LNs and logs?
we're gonna do one right now.
Very fun, no.
We're going to the log cabin and do some math there.
Oh, that's good. That was
Very
good.
funny, very funny.
That was good. I really like that one. Made me smile. This is number 3.
In which section?
That's a good question. The fourth. Which quadrant will you be in? I don't know.
I mean, I figure it out eventually once you start writing it.
Yeah.
Oh, no,
Might as well, right? Now, on the test, I'm not gonna do LOG.
Only that.
Only Ellen?
Only LNs.
Thank you.
All right.
That's something I didn't have to do.
So, what rule?
Quotient rule.
Right, quotient rule. Okay.
I just trailed.
So y prime. So let's remind myself, it's going to be low D high minus high D low over low low. Don't forget the low low. That's a big no-no. Okay. Thank you. So low in parentheses. Got it.
Yes.
Please don't forget parentheses, so then you don't start to get confused as to what connects with what. Low D high. So the derivative of 1, 0, right? The derivative of ln of x.
Ln of x is 1. No, that's ln of e of x, right? Yes? Is 1 over x.
It is.
Ln of e to the e is 1.
The ln of x, its derivative
One over
is
1 over x.
1 over x. This is 0 plus that. Do I have to know that? Yes, 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 I have to know that.
1?
Yeah. Is it on my bright colored sheet of paper? Uh-huh.
Oh, it is?
Wait, why is it?
Wait, it's from the.
It's one of those.
Is it just because it's
Just because it is?
Because you
It's
don't
the-
question it.
That's 1.
Derivative
Okay.
of ln u is 1 over u to the derivative of u, and because there's only one x.
To the derivative.
What the heck?
So let's review that for a moment. ln of x is just a generic. No different than e to the x was a generic. Remember, I said e to the x, derivative is e to the x, and then e to the 2x would be 2e to the 2x. And e to the x squared plus 1 is 2x e to the x squared plus 1. Same concept. You have the ln of x, its derivative is 1 over x. That's generic. Okay? The ln of 2x, the derivative of that would be 1 over 2x. So you take 1 over whatever that is, times its derivative. So times 2. It makes
And
better
then-
sense. So
and then they-
reduce that to 1 over x, right?
Uh-huh.
Yes.
Okay, so it's basically, if you're saying ln of u as the standard one, so it's the derivative of u over u.
That's all it is.
But so if there's
Well,
an x and
yeah.
it's always just going to be 1 over x because they cancel out.
Right. So the way he just said it is u prime, derivative of u, over u. That's all it is.
Or it's the inverse of u and then times the derivative of u.
Right. So let's say, let's get exciting. 3x to the third plus 2x plus 1. Might as well get fun.
That's ugly.
Okay. What do we call u here?
3x cubed plus 2x plus 1.
Junk, right?
Yeah.
So its derivative is 1 over junk, and then
So 9.
I'm going to actually take the 1 over and be done with it because I'd rather have just the derivative on top.
Yeah.
Okay, so let's look at that. So
9x
9x squared
plus
plus 2.
right. Done.
Oh, that's
Now, let's just, because I am going to be teaching you integrals soon. This may go into a couple, like, not next week, but the week after kind of deal because of this, whatever we have. But let's think ahead for a minute. Yes. About what?
I had,
Okay, go ahead.
I forgot.
I don't hear you.
I forgot.
Oh, I forgot too. Okay, good. Okay, so if I gave you this problem and I told you to integrate, remind me a minute what, okay, so I take a derivative, I have the
You bring it
answer.
back.
If I integrate, it brings it back, right? You guys with me?
Yeah.
So,
1 step forward, 1 step back.
times order, right? So if I'm looking at this, the first thing I zero in on when I'm doing these problems is I see I have something on the bottom, and in my mind, if I take its derivative, oh, look, I have it on top. Does that make sense what I just said? So the integral of this, remember, derivative brings it, integral brings it back, right? So if I'm looking at this, I have du over u.
Yeah.
So I have the integral of du over u. By definition, it's the natural log of u plus c.
That's wonderful.
Oh, yeah.
What is a C?
constant.
Constant because
Do we
of
remember the integrals? We have to add plus c if it
Yeah.
doesn't have an a and a b, right?
Oh.
Yes.
But like technically won't we know what C is because,
Depends on if you have an a and a b or a point that it's going through.
well, I mean like for the logs, because when you derive it, the bottom has a C.
Different kind of c.
They'll give you an x and your y. You plug in your x and your y, solve for c, and then
They'll
stick
give
it back
you an
in.
X and a Y.
Okay.
Now, something else to think about. It's actually the natural log of the absolute value of u. What?
What? Okay.
What does absolute value mean to me?
distance.
Distance from 0.
That
It
it
can't be negative.
that it can't be negative.
Mm-hmm.
If you take natural log with your calculator right now, and you start plugging in numbers, let's do that. Take your natural log, take your calculator, plug in ln of 3. You get a number, right? Do the ln of 5. Okay, 1.6. Do the ln of negative 3.
Error.
Oh, really? So how about the negative ln of negative 5?
Error.
Error. ln of anything negative.
Yeah.
If not,
It has to be
it
positive.
has to be positive.
Or if it's negative,
So-
make it positive.
So if the answer turns out negative, we make it positive. So what does this tell me to do with my final result?
Square.
Make it positive. No, you don't square it. You just, the absolute value says, if I get negative 3 in here, make it a positive 3 and then plug it in.
So you can
But you just do
So-
that, or?
positive.
Always. So the actual thing for integration is that. Remember, take a derivative, undo it with an integral.
Miss K?
Yeah.
I thought you had to use the easy substitution, or use substitution if there's something in the denominator.
Listen, the beauty of this one is if I recognize du over u, there's no u substitution necessary.
So you just.
So your first bet is to see if you derive the bottom, if it's the top.
That's what
your
it,
best
like
bet.
when I start teaching you integrals again, I taught you minimal last year. I taught you how to do the basics. But there's some steps that go into it. Step 1, can I integrate just naturally? Step 2, is it du over u? If it is, yay, I got this. You know, is it a variation of du over u? Let me explain that for a second. Like, let's say this was 18 and 4.
Oh.
So what happens here? I've got 9x plus 2, if I took its derivative, right? Oh, shoot, I've got 18x squared plus 4.
double.
Double.
I double it. Oh, I double
So
it.
if you had it
So
two-
what could I do?
2
So
ln.
on that.
I could actually take this and make it a 9, and this and make it a 2, and pull out a 2.
Ah.
Right? So there's things that we're going to learn that if you get back forth, if you get this, then you're cool. You're good to go. Okay. So, but the problem with this is, let's look. I have, you know, ln of 2x, its derivative is 1 over x, right? Cleaning it up. du over u is 1 over x. If I go backwards, I'm going to end up with this, not this. We have things that we need to talk about. Okay? So just keep that in mind for future reference.
When deriving anything with ln, it's just derivative of u over v.
That's all it is. Okay, so where was my original problem? Over here. So I had low, right? D high. Now is everybody cool why the D high is?
Uh-huh.
The derivative of 1 is 0, the derivative of that is 1 over x. So low D high minus high, parenthesis, 1 plus ln of x,
D-low.
D low. What's,
You take
so it's
the derivative of both.
so it's 2x minus
Minus 1 over x.
1 over x.
x all over,
X squared minus ln of x in parentheses squared.
beautiful, done. Do you have to clean it? No.
Good. That's a monster.
Yes.
I would never clean that.
You don't think you could do it?
I-
Oh, you wouldn't clean
Not,
it?
not willingly, no.
No,
Not
no.
willing.
You can pull out a 1 over x,
I'm
right?
with you.
If the problem says you have to simplify it, then.
Actually, no, you can't. No.
No.
Are we feeling a little better?
Yeah.
Yeah?
Okay. All right.
Bunch of x's
Could you
in one.
pull out anything in that?
You don't want to.
You could cancel out an x squared minus ln x with one of the ones in the bottom.
Yeah.
No. but it's
Cancel it out.
subtraction.
No, because it's connected to this. Connected to this.
Oh,
It's different. So you
that,
can't.
so they're really one
Yeah,
whole
so
term.
that's it. You're not cleaning much. do number 9 together.
9 in which section?
So anything that says LOG, we're just gonna kind of ignore, okay?
Yay.
Puerto Rico is
Number 9, you said?
Number 9 is the, yeah, I don't think we've done that one yet, have we?
In the fourth one?
Correct.
Okay.
Yeah, I don't think we touched that one. Almost happy we didn't.
They're already out of power.
Who?
And they don't want French fries.
Are they?
Yeah,
They
I'm
don't
talking to
coming.
somebody in Puerto Rico, and she
Are they
just,
okay?
well, the bad part hasn't hit yet, it's just, they're already out of power, the bad part hasn't.
Well, tell them that prayers are coming from Rockledge. Yes.
So would you multiply it by the reciprocal of the denominator to get rid of that fraction?
I would not. I would use quotient rule. I would use quotient rule. Because we talked about yesterday, remember you said, somebody out there said, but I prefer not to use the quotient rule, I'd rather do product rule. And I gave you my reasoning why we shouldn't, right? I said, don't do it. Okay, so, how do we do this one? I see quotient rule,
Yes.
I see low and high.
Yep.
So y prime is low in parentheses. Are we good? D high. So what's the derivative of 1?
0.
0.
Zero.
Plus.
Good. So plus, I don't really care because it's 0 plus.
5
1
over
X,
5x.
right?
Ah,
It's 5
so,
over 5x,
so-
which is 1x.
so low D high. So D high was, we said 0, doesn't matter. Plus, and then you told me the derivative of ln of x is
5 over 5x.
d over u. So 5
Over
over
5x.
5x.
Which is
One over
1x.
X.
So is everybody cool with that?
Derivative
sounds
of
good.
natural log and it's x with something in front of it, it's always 1 over x.
Right. If it's just a simplistic like 2x or
Yeah.
5x or 3x,
It's always 1.
then I think it's not locked. You want to unlock the door? I think it might be locked.
High D low.
Hey, is it locked?
Yeah.
Really? I've done my part.
Tried the door.
So I did a good job. Hey, yay.
What'd you do?
Yeah, you go.
Okay. Low D high minus parenthesis high
Hi.
D low. Ooh, how do I take derivative of?
It's just
You
one.
bring the two.
It's just 1/2, right? Because it's really 1/2 x.
Oh,
The derivative of 1/2 x. Everybody need to see that?
yeah.
It's really that.
Oh.
Yeah.
And so to take its derivative, 1/2 goes for the ride,
And there's the
and the
other.
derivative of x is just 1.
Okay.
So times 1. So everybody cool with that?
So
Yeah.
the denominator in the original problem had been 2 over x. We could have technically flipped that out, distributed an x to the top, and then
Yes.
had b over 2.
Yes.
Yeah.
But he had mentioned doing it this way. I'm like, I prefer this myself. So low D high minus high D low. D low decided was 1/2.
And then all over low.
All over low low.
X squared over 4.
Oh,
Yeah.
you.
You can clean it a little if you want, like the x's could cancel, so I'm left with 1/2. This is actually not a bad clean.
No.
So those would go, that's 1/2. I recognize 1/2 in common, I could factor that out.
Yeah.
I could flip this guy up and multiply the 4 through. I don't want to do all that. If I don't have